everybody. We're going to go ahead and get started with our first speaker for the afternoon session. It's my pleasure to introduce Dan Buceris. Dan is a swine nutritionist who graduated from Laval University in Quebec in 1996, and his partner founded the Ceres Group in 2004. This company is based out of Quebec, Canada, and specializes in all areas of swine production. The Ceres Group services offer consulting in swine production and general production and the breeding stock and sales of nutritional products. The Ceres Group is also involved in swine production management in a network that produces over 300,000 pigs annually. Dan works on the development and monitoring of nutritional programs for swine producers all over Canada. Beyond its presence in Quebec, the Ceres Group has partnered with the Shakespeare Mill in Ontario, a nutrition partner and farmhouse in Western Canada, in order to work across Canada with all swine producers. The Ceres Group and its affiliates influence the feeding of more than 5.5 million pigs annually, which include consulting for the nutrition and R&D for High Life, one of the top 2 swine producers in Canada. He is also doing consulting in nutrition and production with Tanzhou Breeding Company, located in China, who has 80,000 sows in production. Dan is working with many industry partners to conduct field research projects which aim at developing new feeding programs in order to optimize the performance of pigs, their profitability, and ways to improve their meat quality. He has done many presentations for producer meetings or at different conferences and seminars in swine production. Today, the Ceres Group and its other business partners employ more than 100 people and are committed to continuing to work with Canadian pig producers. Dan's talk today is entitled The Importance of Research in Driving Decision-Making in a Swine Production System. So let's welcome Dan.
Thanks. So thanks a lot. Good afternoon, everybody. Thanks for being here. So I guess John said this morning there was some foreign speakers. I'm probably one of them from Canada with my French accent. So yeah, I'm going to talk about R&D today and a bit how we use R&D to make decisions in production system. So I just want to start. Normally we do that at the end, but I want to take some take-home message that I want you to remember about that presentation. So one thing that I find very interesting that we have to remember is that the only thing that making decision based on no information is to make a decision on wrong information. So that's why when you do research, you better do it well, because if you have the wrong information and you make a decision based on that, it's a bit of a shame. The other thing that we always try to keep in mind is that when you do research, we try different products. Product A, product B, one is doing good, one is doing good, but sometimes most of the time they are not additive. So we always have to be careful when we do research to go back in time and reset what we did 10 years ago is still of value, because we did a lot of change over the last 10 years. So the product that we've been using since 10 years is still of value to use that product because of all the change we did since then. So we have to keep that in mind. It's easier said than done because we cannot always redo the research we did 10 years ago, but that's something we have to do sometime. And the other thing that is really important, coming back to my first message up there, if you do R&D, do it right. It's really important. So I got an introduction from here before, but I just want to go through some keynote about what we are. So because most of the people in the room may not know about me too much because I'm from Canada. I'm not highly involved in the U.S. Pig business unless coming to some conference a couple of times a year. So we founded Groupe Ceres in 2004, myself and my partner. Like we said, we are involved in all areas of swine production. Nutrition is a big part of our business. Consulting, sale of premix product, VTM, complete feed. Started our business in Quebec, but we grew Ontario, Western Canada over the years. We do a bit of genetic. We have a dealership for FAST, which is now AccuFast, on the female side, and we work with PAC on the sireline side in Quebec. We manage about 250 boar in a boar stud, and we sell about 35,000 gilt a year in Quebec for FAST. We have skin in the game. We produce pigs, so we know what it is to lose money with pig production and to have some challenge. 250,000 pigs a year, more or less. High Life is a partner in our business, and we work really closely with them. High Life is 2.5 million pigs a year, so we know when we talk about pigs, we are involved in pig production. And when I say that we have skin in the game, we also have blood in the game because we started a packing plant which we bled a lot. We started that 2.5 years ago. Small packing plant in Quebec that was an empty plant that we took over from a group that started that plant early 2000. That plant was closed down since almost 15 years. Bought back the plant, did some renovation, and started to kill pigs in November 2020. And I can tell you it's a tough ride. Today we're close to 500,000 pigs a year, which is not very big based on the US standard. We want to go to 1 million pigs a year by adding a second shift, but we need to make some money before to do that. So it's not an easy one, but we think that for the future of our business to have packing industry, packing access is a good thing for us. This is a bit how we are spread in Canada for the nutrition service. Different name, different company, but we all have partnership through Groupe Saraies in those business. So we cover all Canada. Also, we do a bit of poultry, a bit of dairy, beef, here poultry as well. We have a dairy business in Quebec as well. So, but mostly swine on my hand. The only thing I know is about swine. We have a collaboration with a vet group that started their business same time as us in 2004. Great partnership because vet and nutritionists sometimes they don't always work good together, but because we work really closely, I think it's a value for our group. Like we said, we feed about 5.5 million pigs in Canada, 20-25% of the market. But the biggest thing of our business, in my mind, is doing the research that we do, and I'll go through some of that in my presentation. We have done over 600 research projects over the last 17 years, I will say, about 30, 40 projects a year that we do on an ongoing basis. So research setup, just for you to know how we do research. We have 2 sow barns, both located in Manitoba, Bonanza sow, 1,200 sow on a weekly batch farrowing, and we have another barn, 1,300 sow, that is on a 4 weeks batch farrowing where we do sow research. 2 nursery barns, one in Manitoba, 1,200 head, 1,000 head in Quebec, really close to our office where we do nursery trial. And we have, it's not 40, it's 4 finisher barn, Highlander, which is on the same site in Manitoba, over 1,000 head each, and we have a smaller finisher barn in Quebec, 500 head, where we do research as well, and we do use other barns to do research projects as well. So when we talk about R&D, I like to define R&D in 3 types. This is my own definition, so I didn't take that in Google or Wikipedia. I see research in three categories. So fundamental research is what I call research by university, specialized research center, where you look at discovery, exploration, trying to find new concepts that may not be on the market right now. They may not be, most of the time it's not practical at first because you're just doing some discovery process. The application may be long-term, not short-term, so it's not an access tomorrow morning for the industry. And most of the time, you didn't think about them being cost-effective. It's not the goal. You may have to think about that later, but the first goal is not to think about is that concept is cost-effective. I just want to prove if there's value to look at it and develop something later on. Applied research is like a follow-up of fundamental research for me. You found something on the fundamental side, you look at the concept, you want to validate it, so you go to a university farm, research, specialized farm, you can do private industry. It's just another step that gets you closer to field application. But it's not always what meets the need of the industry. It's still something that you have to refine after. Practical research is what we do, what I think we do the most in our system, in our industry, or what we do with our group, because that's what drives our management strategy. Again, we try to be more specific to a product system or portion of the industry. You know, if you think about, we do research sometimes that apply in Quebec but not in Western Canada because we don't use the same type of grain when we feed our pigs. We think it should be closer to the needs of the producer. We talk about in-farm production research, so we use real farms that have been set up to do research. It's a faster and more direct application. The most important thing is that we have to validate the ROI. We have to make sure that we do something that will bring back money to the producer or to the industry after. But you still need the rigor and the structure to do good research. One thing that I'm really convinced that research is really important for the industry. If you don't do research, it's pretty hard to progress. You know, to make decisions, you need data. To get data, you need to do research. There's different ways to do research, but overall, to be innovative, you have to do research. And aside research from university, a specialized research center, supplier, a lot of suppliers in the room that do research as well. I think the internal research that you do at your place or as a group of producers together is the last piece of the puzzle to make the difference. Okay, not all producers can do research. It's a fact that if you have 1,000 sow farm, you may not do research, but you can have access to research with your nutrition company, your vet group, or with some independent research group that you can use their data to get and move forward. And like I said, research will help to make decision strategy. How do we decide to do research to make decision after? In our case, we need to involve the whole team. It's not just about me or the nutrition group that makes decision about research. The nutrition, the production, the health, and other if needed. So we go together, we talk together, and we put upfront our project, the priority, and what we think as a best ROI for the business. Okay, so we try to list all of that before to make decision on our research project. The other thing that we have to think about, can we implement afterward? We can have a great idea to do something that may work, but are we able to implement in our production system? Sometimes you have to invest, takes time, you have to change the barn. You don't have the staff to do it. You can ask the guys to grab every pig's at birth and give them a shot of colostrum. It's working, but people have a hard time to do that because of labor shortage. It doesn't mean that you don't want to do research on that, but implementation is really important. Do I need capital investment? You have a project, but you need to spend millions of dollars to make it happen. Today, with the situation in the industry, it's a bit hard to ask money sometimes at that high level, so you have to keep that in mind as well. And what are the chances to make it with a success, to be able to have money return on investment after that? 5 years ago, I went back to all the data we have on feed additive. We do a lot of trial on feed additive, nursery, finisher, sow, and only 15 to 20% of the project were showing a positive income, okay, and a payback. And those projects, we select the one that we think would work. We don't test whatever come to us. We do a screening, we select the project, the product, the concept that things would work, but only 15, 20% of the time we have a positive outcome. So not saying that 80% of the time the other products are shit, are not good. It's just that in our case, we didn't have success to work with those products at that time. At the same time, although we need to decide about projects that we think will have a value for us, we have some time to take risk. And I like to say you have to think outside of the box and maybe try things that you may think will not work at first. Okay? We have perception, we have ego, so sometimes we have to forget about that and go see what other people are doing and see if those things can help you in your business moving forward. One of the things that we have done over the years, we have done a lot of work on low zinc diet. In Canada, we're going to have to take out zinc by 2026. 2009, we started with our first project to feed low zinc diet to our weaned pigs. And I'll show you some data quickly on the next slide. It was a bit of a failure, okay? So we did 13 trials so far. And in 2018, we went in Europe, met with a group over there, look at what they have been doing in Europe because they are feeding low zinc diet, and now they are doing everywhere in Europe since June 2022. And we took what they are doing, adapted to our own situation, and worked on that to improve our program on a low zinc diet. And we have been able, since then, to feed pigs with lower zinc level without compromising performance. Okay? Well, this is a bit what we have done. We have 13 trials we did on zinc. First one in 2009, this one was just finished early this year. This is the average daily gain of the low zinc diet versus the high zinc diet. You can see that the first 6 trials, every time we remove zinc, we went from 2,000, 2,500 to 250 ppm, we were losing performance and growth. Every time. 6 in a row. 10 grams, 25 grams. It was not always highly significant, but I just look at the raw data, and every time we were under performance with high zinc diet. In 2018, we changed our feed program. Lower energy, protein, using fiber, looking at ABC4 value, other stuff as well. We did a whole shift to our program. And then, since then, every time we do a nursery trial with low zinc, we've been able to improve performance or have the same performance on growth. So, big shift by thinking outside of the box and looking elsewhere. On mortality, same thing. Most of the time we were the same, but some trial we had higher mortality. Since we switched our program, the mortality has been as the same or even lower most of the time. So, just an example of a long-term project, and we keep doing research on that, but we've been able, by going see what people are doing elsewhere, to make decisions and be able to reduce our zinc. Today, at High Life, we are feeding 2,000 ppm of zinc in our first phase for 5-7 days, and after that, we are at 250 ppm of zinc all the way through. Okay? And we, not meaning that we never have challenge with E. coli or scour, but things are going pretty well. The other thing that is important on the decision process is that you may want to involve people that may not have your expertise. Okay? Sometimes, like I said before, we have perception and we have ego. And we think that things should go that way. So even though when we talk about research, we say, because I think it's going to work, I'm going to do it that way. That could be a problem if you have too many people that think the same way in your research group. And with experience, those things can happen. One of the examples that we have at High Life, about 6-7 years ago, they started to hire what they call co-op summer student. All those people were having an engineering background. No clue about pig production. They were just smart people that had an engineering background. They came for summer, and High Life was giving them a project to fix a problem or to try to get data on something they didn't get the data. And we realized with those people, because they have no bias, they are seeing things a bit differently than what we do. So we brought those people into our research group, and we give them some project to work with us. They don't have the expertise, but they learn quick, they understand, and they know how to process data, which I'm 51 years old. I'm not the best guys on computer data, but those guys, they know how to take data, process data, and use the data to make decisions after, and run research projects as well. And the way we use those people is that we have a problem, and they work on finding a solution without any bias and looking at everything at the same time. We just have to give them direction to make sure they don't get lost too much. But we have a project going right now on pre-weaning mortality where they look at all the things that can impact pre-weaning mortality, and we try after that to define some research project that will try to fix the problem. So just think about bringing people that may not have the expertise and the knowledge that you have on the pig business and nutrition or health, but those people are a great asset for the business. When we do research, we need to measure. It's really, really important. As I said, you have to do it right. There's no room for guessing or perception. We work with customers sometimes, mostly out west, with Other Right Colony in Canada, where they like to look at the pigs and things that, by looking at the pigs, they're going to see if the pigs is doing better on the program versus the other program, because they like to challenge our feed program, those guys. I'm not a big believer of that. You need data, and you need precise data. Because the differences are small, and most of the time they can have a big economic impact. Okay, you're not going to find 10% improvement in average daily gain by testing a feed additive. Okay, unless you talk about Paylean and Improves and those type of things, but you know what I mean. It's often small difference you need to measure to make sure you capture those differences. If you need to weigh the animal, you need to have a scale. You don't look at the animal and things that are bigger than the one beside them. You need to have a scale and to weigh the animal. Feed intake, you need to measure feed. You don't use the feed bin inventory on one side of the barn versus the other side and try to estimate feed efficiency based on that. You need to measure the feed by pen with precise measurement. Okay. You need experimental unit. You don't test a room versus a room. It's pretty useless in my mind. We do pen or we do pigs. Pen because we measure feed intake by pen most of the time. Pigs, you can measure the weight of the pigs, but most of the time we're going to do it by pen as well. Using a room, like I said, a barn or a section of a barn, for me it's a bit not the best, although you can do it if you have multiple replication over time. Like I said, if you measure weight, you can measure pigs one by one, but feed intake, it's pretty hard to have that unless you have an individual feed intake system, but most of the research barn will have pen feed intake data. And when you have the experimental unit, you need to decide how many you want, how many you need, because after that you're going to run stat and you want to determine is the difference is due to the treatment or due to chance. So everybody knows in the room when you do research, you need multiple replication, whatever you call it. You cannot compare one barn versus the other barn. In my mind, it has very little value. Okay? And some people do that sometimes, and I'm not saying it's not right to look at it that way, but it's not for me true research. Can we compare performance before and after? I don't think it's a good way to do it because you have so many things that can change before and after that is over the treatment or the concept you want to compare that way. The only thing you can do the before and after, and I'll show you that at the end of my presentation with an example, is just a validation of an implementation of something you did on research and try to validate if what you did on research is found in your production system after implementation. Just a little example that I like to show to some producers sometime about doing research a different way. Here is an example of a trial that we did in nursery where I took 3 pen 1, 2, and 3. Each of those pen was on a different feed treatment, A, B, C. If you look at pen A, 1 and 2 on A, B, you can see that those pen were having better average gain, lower feed efficiency versus pen C. But when I took all the pen I had on the trial, 16 pen per treatment, and I run the stat, the winner was treatment C because the growth was better and the feed efficiency was the same as A and lower than B. So comparing one pen versus one pen, for me, it's no value to do that. You need multiple replication. And the statistic after that comes if you have good experimental design, good experimental unit, enough repetition, you can run the stat and find out if the difference is from chance or from the treatment. Everybody know about the p-value. Most of the time, you need a 0.05 and below p-value to publish your data. In production system like we run, I'm not really crazy about that 0.05, 0.1, 0.15, depending on the outcome, the economic impact, and all the things. We can use a bit of our common sense to make decision. The 0.05 is kind of the ultimate goal, but around 0.1, in my mind, should be a good value as well in terms of a p-value. And the final one that I find sometimes we are missing the most in some of the data that we see in some conference is there a positive ROI? Can you pay for the project you've been using? You can pay for performance. Here an example that just a fake example. You have a feed cost that costs $8 per ton, $2.20 to $2.30 a pigs. You expect to improve feed efficiency by 2% with that feed additive, which is about $2 a pigs at $375 per ton. You still lose money. So even though you improve your feed efficiency by 2%, which everybody will like to improve feed efficiency by 2%, that $8 per ton investment was way too much. Was too much. You need to be at $7 to break even. And normally you don't want to use a product just to break even. Okay? You want to make money when you use those type of products. So it's really important to run economics and to think about that. Sow trial, that's probably the most challenging research area that we have to deal with. To run research on sow takes more time, and you need a lot of sow. Here, I just throw a number that may not be the right number, but when I see data on sow trial with less than 50 sow, 12 sow per group, 20 sow per group, my mindset closed pretty quick. I'm not really interested. Not saying that the data have no value, but you need a lot of sow, okay? And I'll show you some example of that. There's some challenge to do sow trial. You have to measure feed intake, body condition loss, litter weight. In our research barn, we measure all of that. We measure all the pigs at birth one by one, all the pigs at weaning one by one. We measure the back fat of the sow, the weight of the sow, pre-farrow. At weaning, we measure feed intake. We have a computerized feed system in our research barn, but it's not always easy to do. You need the equipment and the time to do it. The other one, like litter size, stillborn, you have that from your production record, so those ones are easier to gather. But like I said, there's a large variation in sow performance, which means you need a lot of repetition if you want to see some significant difference. On the other end, when you do sow trial, the investment per sow is spread out over a lot of pigs. So that's something that is interesting. For example, if you feed an additive in lactation that costs $15 per ton, and you wean 30 pigs, it's about 20 cents per pig. So that could be okay for a return on investment. But if you feed that $15 both in gestation lactation, then it's 60 cents a pig. Then you have to get better performance to justify the investment. The other thing that we have to consider when we do research in sow, think about the parity. P1 versus P5, they don't perform the same. So when you do treatment allocation, you have to do it within parity group to make sure you have an even distribution of your parity within the treatment. So example of how many sow you need to detect some difference in the sow trial. Just an example here of litter size. You're at 15. You want to detect a difference of 0.05 increasing by 0.25, you need 1,400 sow. If you're at 0.1, you need 1,100 sow. This is based on your standard deviation. So you can lose your data from your system, look at your average performance, your standard deviation, and you have some model that can tell you how many sow you need per treatment group to detect such difference. If you want to detect 0.75, which is for me a large difference, you still need 150 to 120 sow. So when you think about 20 sow per group in a trial, I guess you need about 2 pigs more to be able to have a p-value that is significant. So a lot of sow. If you do pre-weaning mortality, it's even worse. You want to drop by 0.5, you need 2,500 sow. If you want to drop by 1.5%, if you want to see an improvement by 1.5% being significant, you need over 250, 275 sow. Because pre-weaning, it's either sometimes 0 or 50%. So the CV is pretty big. So you need more animal to detect those differences. I don't want to go too detailed on that, but I was talking about economics. So we have an economic model that we use every time we do a project. We look at the potential outcome and how much we can make or save money versus the investment that we have to do. So just a couple of parameters that if we look at improving the weaned pigs. We know it's $38 per sow per year based on market condition at that time. If we reduce mortality by 1%, it's $12.50 per sow per year. So if you do a trial and you want to reduce mortality by 2%, and your investment is less than $25 per sow per year, there could be a payback. Okay? So those things have to be kept in mind. If you measure lower back fat, weight loss, feed intake, it's pretty hard to put a dollar value, but you will think that those, if you improve that, you should have better performance after that. Nursery finisher, those are more common research, because they are easier to do. Nursery, it's about 2 months. Finisher, 4 months. If you do a wean to finish, it's 6 months. We don't have a lot of wean to finish operation in Canada, so we have side 2 nursery, side 3 finisher. That's how we divide our research. There's so many product concepts that we can try in those areas. Most of the time, we'll look at pen versus pen, multiple pen for the experimental unit. Average yield gain, we do some residual weight sometime, but most of the time we'll use a pen weight to get feed intake and feed efficiency on a per pen basis. In all those trials, mortality is really hard to assess. You can have difference in mortality, but again, the number of applications to have a p-value that is highly significant, unless you have a big difference, it's pretty hard to assess mortality difference in those type of trials. And when you do allocation, you need to account for the weight, the age, and in finisher, you need to account for the gender. In nursery, there's no big difference between male and female in terms of performance. So same thing on the experimental unit requirement. If you look at average daily gain, if you want to improve by 2% and have a p-value of below 0.1, you need about 40 pence per treatment. If you think you're going to improve by 6%, which is a lot, you can do with 5-6 pence per treatment. So most of our research trial will be between 12 and 20, 24 pence per treatment. We never go below 10 pence per treatment when we do nursery and finisher trial. Same thing, we look at the economics. If we improve average daily gain on a fixed time or a fixed weight basis, this is the improvement on a per pig basis, feed efficiency, mortality, and then if you have to invest $25 per ton in nursery to get those performance improvement, you know that you won't be able to make it if you just have 1.1 pounds at the end of nursery. You need more than that to pay for the 85 cents per pig investment. So again, something to keep in mind. Finisher, about the same thing. On average daily gain, you need, depending on how much you're going to improve, you need at least 10, 14, 20, 25 pence per treatment. Okay, if you talk about 2-3% improvement in average daily gain. And same thing on the economics, value of gain, value of feed efficiency, value of mortality, and 5-ton investment is about $1.40 a pig. So 5 ton versus the weight gain improvement, you don't pay for the benefit. So too much money invested for the payback. So you have to think about that. So this is a finisher feed trial that we did years ago, and that's an example of a process that we did to make decision and the validation of the process after. So long time ago with High Life, all the finisher barn were having a tube feeder. The brand name was Tubomat. So those tube feeder in the middle with the two space on the side. Everybody was calling those feeder Tubomat, although there was different brand. That's what High Life had in all their finisher barn. In the research barn, when we started the research barn, we put Crystal Spring feeder. And we found when we first did those trials, the pigs were growing like crazy. So we thought, hey, is there a feeder impact on performance of those pigs? So we did some trial on that. So we compared those tube feeder with what we call the wet-dry Crystal Spring 48 inches 3-space feeder. Okay, this is about 15 inches space per space and 22 pigs per pen. So a lot of feeder space. Even with the tube feeder at 22 pigs, we're not too restricted based on the recommendation from the supplier and what we thought will be fine. So we're not expecting to have that much better performance, but we wanted to test it. So more feeder space with the Crystal Spring versus a tube feeder, and we did those trials in 2013, 2014. So this is what we call our Crystal Spring feeder. This is a feeder with, you have a kind of a plateau here where you can have the dry feed, or the pigs can get the feed at the bottom, and you have nipple at the bottom of the feeder, and you have those tube feeder, that was what I was talking about, and you have 22 pigs here, 22 pigs here, and here were 22 pigs and 22 pigs on the other side. Look at the performance difference. Those pigs were not that much heavy because it was, in 2013, we were shipping pigs a bit lighter at that time, but we had a 20 pounds difference at the end of the finisher phase on the Crystal Spring feeder, 20 pounds. Carcass weight was the same, the yield was the same, so the difference was about 18 pounds here when you look at the carcass yield. We do it with heads on and the feet, so it's higher than you guys in the US. Average daily gain was 10% better. feed intake was 10% better, and feed efficiency was the same. But if you look at the same feed efficiency for higher weight, if you adjust for the weight, we had better feed efficiency on the Crystal Spring because the pigs were heavier and they end up with the same feed efficiency at the end. Those pigs were a bit fatter because they grew much faster, but the loin depth was better as well. Okay, but it's based on weight at the same time. Okay, so big difference on performance. And I just want to show you quickly when we measure, we weigh pigs every 3 weeks, and every period, even at first, even though the pigs are small, we had better growth on the large feeder. There was more pigs eating at the same time. I remember I went to the barn at that time, and there was 5-6 pigs in those big feeder, eating at the same time because those pigs were 25, 30, 35 kg. So at every 3 weeks, we had better performance, even though at lightweight versus at the end of the batch. Okay, so when you look at the economic impact, it doesn't take very smart guys to understand that the difference was huge. We were about $5 to $6 per pigs based on fixed time or fixed weight, depending how we do it for the finisher. The extra cost of those feeder was about $200 per feeder. Okay, so over 15 years, it was 10 cents investment because I did, 25 pigs per side, so 50 pigs per feeder, 2.75 turn a year, over 15 years lifespan of the feeder. That's about 2,000 pigs that feeder will feed, and you pay $200 more. So it's about 10 cents investment to get that payback. But you have to install those feeder and things like that, but the payback is huge. So what we did at High Life, since after that trial, we did another trial comparing 2 and 3, and we thought that when we have more pigs, we're going to put the 3 space, less than 25 pigs. We felt the 2 space was good enough, so that's where we did. We changed over 2 years over 8,000 feeder, so it was a big investment. Okay, and by doing that, when we did that, we're still comparing the batch with the tube and the batch with the new feeder to make sure that the data that we have from our research was still the same in terms of difference in performance. So that's what we did. I didn't do that for 10 years. I just did that for the year when we did the transition. So we have the closeout with the tube feeder, and at the same time, we were changing some barn with the 2 or 3 space feeder, and I tried to compare the closeout that had the same health status, the same genetic, and everything like that to be as good as possible. And although the difference was not 20 pounds, we still had that 10 pounds difference. And when you look at the weight, we were having slightly better feed efficiency. Okay, so I was having a $5 to $6 per head return when I did my first calculation. Now it was 4 to 4.5. Okay, so not as good as my trial data, but still a big payback. So we kept going and we changed all the feeder over time. And honestly, the tube feeder, even in Quebec, we did some change with our customer. We proposed them that when it's time to change, to put those new feeder, and everybody's seen an improvement in performance by using those larger feeder. Okay. So that's an example of the process that we had in terms of research and making strategic decision and try to validate those decisions after that. So I think R&D should be part of your organization. Either you do it yourself or you align with people that do R&D and that share R&D with you. The supplier, the university will do research, and that's fine. But doing your own research, like I said, it's the last piece of the puzzle to make your decision and move forward with confidence about what you're doing. We are investing a lot in research. We are investing about $1 to $1.5 million a year. In Canada, you have what we call the SHRED program. So it's a tax-credit program. I don't know if you have that in the U.S. to the same extent, but we have about 30-40% of the expense in R&D can be claimable on tax. It used to be really easy to claim those expenses. Now government is a bit more, because I think people abuse of the system sometimes, so it's much harder right now, but overall we can get 30-40% kickback on tax credit. Like I said, R&D is investment. You have to spend the money up front, but over time, if you do it well, you have a return on investment. So we did some enzyme project over the last 2 years. We did 6 trials on enzyme. Nursery finisher, with the high feed cost, I revisited the enzyme value in our program, and our trial data showed that we can save about $2 a pig doing enzyme in nursery finisher based on the research we did. $2 a pig, just for High Life, it's $5 million a year. So even though they invest $1 million a year in research, just that 6 project trial that we did over a year and a half, 2 years, pay back 5 times the investment of a 1-year research program, or 3.5 times if you spend a bit more money. Communication with management is key if you want to have their support. So at the nutrition level, production level, we make decisions, but the guys that pay, like, for example, High Life, the management of High Life, which are not involved in the research day-to-day basis, you have to communicate with them and show them the value of what you're doing. So when you ask for investment, a new feed system, a new research barn, those guys are willing to do it because you show the value. And we have a monthly meeting with the R&D team just to see where we're at and try to do every 4 months or 3 months a meeting with the management. We try to do it. It's not always happening, but we try to communicate with them the outcome of the research so they keep supporting us in our research program. And for us, the value for our customer has been huge because we transfer that research to our customer base as well, and they see the value of working with us because we have those data, and because we use it as well, because we are on both sides of the game, you know, the fence. We produce pigs and we feed pigs with our customer. They see value in what we're doing for the system as well. That's all I had for you guys, so thank you for your attention. If you have any question, I'll be open to it. Yeah. That could be it. Sometimes you do research, you say you want to test something on E. coli challenge, but your farm system is so well managed that you don't like E. coli. You know what I mean? Or maybe because I'm too good of a nutritionist, I don't need those products. No, I'm not saying that. No, but you're right. So but if they will work at 50%, I will be a bit concerned as well. You know what I mean? So it's not because, and you do one trial, and sometimes you do a trial, you succeed, you repeat, and you fail. So sometimes we don't repeat a lot of trial because if it succeeds, we want to keep it in mind that it's a good trial. But sometimes 2 years after, we redo the trial with the same concept, it's not the same outcome. But 15-20% was a bit of a surprise, but at the same time, if it will be 50% plus, I will be a bit shocked about that as well. Other question? Yes?
My son is a civil engineer. I've been in the pork industry over 50 years. I don't think there was any time I could have talked him into being in the pork industry.
Yeah.
I was intrigued by your comments about, I agree with everything you said about the numbers, about them engaging the numbers and being analytical.
Yeah.
But I don't think I ever talked to you. How do you?
Well, you know, like I said, High Life, they have a program like the co-op student program. So they take those co-op students that are in their process of engineering. So they haven't made a decision on what they're going to do, you know. And like I said, they are not probably meant to do civil engineering. They have an engineer background, but they're not to be a civil engineer or a mechanical engineer. There's different type of engineering program in my mind. So, and you take those people when they are at school and try to show them the value of working with the pig industry. And High Life, you know, in Canada, the strength they have a very good business model, and people are attracted to work with them. And they work with a large company, you know, and they have some engineer value because they go to the feed mill, and feed mill is a big system where you need your mindset of being an engineer sometimes to work with the data. So the one that work on the farm side may be less of those type of people, but the one that work at the packing plant and at the feed mill, they have those engineer mindset, and they see value of being an engineer and helping that company. So, yeah, you had a question?
Yeah, the enzyme that you had success with, I assume that was a blended.
Mostly xylanase, you know. And again, I was not a believer of enzyme, but we are using more and more fiber in Canada in our feed stuff, and wheat, barley, corn sometimes. So even in nursery, we've been using fiber in nursery. So the use of an enzyme, when you use fiber, you had some value to the enzyme. So because we tested enzyme 10 years ago and they were not working really well. Not saying they were not working, but the payback wasn't there at that time. But and we repeat those trials to make sure, because I was surprised the first time, and I did another time and a third time. And when you have 3 times in a row the same type of response, I guess you have to move ahead and do it. All good? Thanks a lot.
Yep. Let's thank our speaker one more time.